In this video, I'll be showing you how to weld using a flux core wire welder. Before we get started, here's some of the equipment I'm going to be using. First off, here are the clamps. These are used to hold together a couple pieces of metal so that they could be welded. Here we have some adjustable locking pliers, also known as vice grips. Here we have a corner clamp. This is good if you're trying to weld two pieces of metal at a 90-degree angle. Like say if you have a couple of pipes you want to weld together for a gate frame, these come in very handy. This is a C-clamp. This works really well. It can take a while to get it clamped though. These are locking C-clamps, and these are the ones I most commonly use. They're adjustable and they clamp on real quickly and unclamp quickly. Next, we have an extension cord. When you're connecting a weld to an extension cord, you want to make sure that you have an extension cord that has wires in it that are thick enough to provide enough power for your welder at a given distance. This extension cord I have is about I think it's a 100-footer, and I believe it uses 14 gauge wire. So you know, this is a nice heavy extension cord, and this provides plenty of power for my welder. Next we have a wire brush and some galvanizing spray paint. This is used once the welding is done to clean off the welds with the wire brush and then paint them with this galvanizing spray paint to help protect the welds from rusting. And last, this is the welder I'm going to be using. This is a Lincoln Weldpack 3200 HD. This is a pretty old welder, and it's been through a lot. So as you can see, it's missing the door. It's pretty dirty, but it welds like a champ. Alright, next I'm going to go over the safety equipment that's required for welding. First off, you should have some good work boots. These are leather. As you can see, these have a bunch of black dots on them, and that's from sparks that have fallen on them during welding. And if you use, say, like sneakers or you know some cheapo work boots or something, sparks can burn through and burn your toes. So it's important to have some good heavy work boots, preferably leather. Next, you always want to wear long pants. Something that's heavy like a jean material or something, because those sparks, you know, they'll burn through thin materials. Alright, next thing, I'm wearing a long sleeve shirt. This is not sufficient for welding really. They make special jackets that are fire resistant, that are specifically made for welding, and those are what you really should use, or some sort of jean jacket, just something heavy, because again, sparks are going to be hitting your arms and everything. Now, welding gloves. Here are a pair of gloves that I used for a long time, and as you can see, they are really beat up. These are cheap gloves. I think I paid about $5 for these, and the seams are coming apart and everything. They're pretty much garbage. These are another pair of cheap gloves. These were about $10. I believe these are better quality than these. I'm gonna find out. But if you can afford to buy real good quality gloves like Lincoln or Miller, you should do that. Alright, next is the most important safety device to have while welding. This is a welding helmet. The main purpose of this is to protect your eyes. As you can see, you can't see through this lens, and that's because it's tinted to be extremely dark. And the reason for that is that once you start welding, the welding lets off a very bright light, and that light is so bright that it can make you go blind, and it can damage your vision. It's very bad to look directly at it. So when you have a welding helmet and it has this dark tinted lens, once you put it on, you can't see, but when you start welding, the light is so bright that you can actually see the welding, yet it's not too bright that it harms your eyes, since this is tinted. The helmet also provides protection because it covers most of your face area. And yeah, you never want to weld without a welding helmet. It's extremely important. Next thing, here's just a typical baseball cap. They make special caps for welding, again, fire resistant and everything. But it's a good idea to have these, and you wear it backwards, and then you wear the helmet over it like so. Because when you're welding, sparks can fly and hit your head. You're welding down like this, you're probably not going to have sparks flying up that high, but it could happen, and especially if you're welding kind of high, because then the sparks are going to want to fall downward, and they can fall down on you. So a cap helps to protect your head and your hair from getting burned. Alright, next there's some safety glasses. Most people don't wear these while they weld because they figure that the helmet provides enough protection, but sparks can get inside the helmet. They can fall down this way, hit your head, bounce into the area where your eyes are at, and it can be very, very dangerous. If you get sparks in your eyes, it could blind you, so it's a good idea to wear these along with the helmet. Okay, next thing I'm going to do is to set up the welder. First thing I need to do is to change this wire out. If you have a brand new welder, the removal of old wire probably won't be something you're going to need to do, but I'm just going to show how to do it so that you know how to swap wire. First thing I'm going to do is I'm going to go over to the stinger, and I'm going to clip off the wire that's sticking out here to make sure it has a nice clean, the tip of the wire is nice and clean so that it'll come through easily. Next thing I'm going to do is I'm going to bring down this little spring, and then this comes up to relieve tension off the wire. And then the next thing I'm going to do is just spin the wire out. While you're spinning it like this, you want to make sure that you're holding this end, because once it comes out, it can unspool and the wire can fly all over the place. So you want to make sure you have a good hold on the wire. Okay. Now that I have the wire all wound up, I need to stick the wire through one of these holes, like so, and I need to bend it over. Alright, now it's safe to remove the wire. Okay, alright, now's the part which is what you'll probably have to do if you have a brand new welder. It's time to put in the new wire. This is the wire I'm using. As you can see, it's much larger than this old wire. That's because this is a 2-pound spool and this is a 10-pound spool. The only difference is just the amount of wire that each one has. I'm switching to a 10-pound spool because this will allow me to weld longer before I have to change the wire. Some welders, like some of the cheapo $100 welders, can't hold a big spool like this, and you have to use the smaller 1 or 2-pound spools, and that's fine, but if you can get more weld time, why not? Just to show you, this is the type of wire I'm using. The thickness of the wire is 0.035 of an inch. This is NR211 MP wire. This is very good wire. The thickness of the wire is something you have to take into consideration with what you're welding. 0.035 of an inch is a good mid-range wire. You can weld, thin gauge stuff and thick gauge stuff. I think you can weld up to maybe a 1/4 inch with this type of wire, something like that. So this is the type of wire I'm going to be using. Alright, now on my welder to switch from the small spool here to the larger spool, I need an adapter, which is what this is. Alright, now that the spool's installed, I need to fish the wire through the cable so that it can be fed to the stinger, which the stinger is the end you hold that you weld with. So, gotta get this wire out. Okay, now I need to clip off the end so it has a nice clean edge. And now the wire needs to be straightened for the first about 5 inches, 5-6 inches, so that it'll feed through this assembly easily. Now there's a couple little holes you gotta fish this through. Alright, got it through one. Now, alright, the second one. Alright, now that I got it in there a little ways, gotta push this little piece down, pop that over it, and now we're ready to feed the wire. Another thing before you feed your wire through, here's your stinger, and at the tip of your stinger is where the wire is going to come out at. And inside of here you have a little copper tip, and you got to make sure that that copper tip is the right size for the wire that you're running. This is the type of copper tip I'm referring to, and has threads on here where it screws onto the stinger, and it has a number on it. Maybe a bit difficult to see, but it says 0.030 of an inch. Alright, so this is the wrong tip for the wire I'm running, because this is 0.030, and the type of wire I'm going to be running is 0.035 of an inch. So the tip I got on there is 0.035. To check it, you have to pull this little cover off and check the number that's on it. If you have to change it, just unscrew it and screw the right one on. So now let's feed the wire through. We're going to turn on the welder, and you got 2 knobs on your welder, or at least I do on mine. One of them is the power setting. This adjusts basically how much power is going to be going through the wire, and you adjust that depending on the thickness of the metal you're welding. And then the next one is the wire feed speed. Right now I'm going to turn it all the way up because I need to feed the wire through, and I want it to feed through quickly. Stretch the wire out straight, and then just hold this button, and I can see over there that it's feeding normally. It's not jamming up. So now I just gotta wait for the wire to pop through the end. Okay, there's the wire. So the wire's fed through. Now that the welder's set up, it's time to start welding. So here I have a couple of, looks like 1/2 inch by 1/2 inch square tubing. This is just some scrap metal. When you first start welding, it's a good idea to just start on, start welding on some scrap metal that you don't care about, because when you first start welding, you're most likely going to screw up. And welding is one of those things where it's like many things where practice makes perfect. Your best teacher with welding is going to be practice. So you just gotta keep practicing on things that aren't really important before you actually start welding on your main projects that are going to require nice strong welds. I need to adjust the welder now, so I'm going to look at the gauge of this metal. It's not very thick. Since the metal isn't too thick, I'm going to adjust the power to C. The thinner the metal is, the lower the power setting should be, and the thicker it is, the higher the power setting should be. I'm going to try C. C might be too much. I might have to put it to B. I'll know if it starts burning through the metal while I'm welding. Alright, and for the wire feed speed, I'm gonna put it at probably about 3. I'm gonna go ahead and clamp the two pieces together using my clamp here. Just gotta adjust it to the right size. Okay. Alright. Now it's clamped together. They're not going anywhere. So I'm just gonna run a weld along these two pieces, see how it comes out. It's also important that you put your ground clamp on what you're welding. The basic way that welding works is it's kind of like if you connect the negative and positive terminals of a battery. And if you do that, you usually will get some sparks, like if you did that with a car battery. And that's pretty much how this works. You have a ground clamp which provides either negative or positive continuity, and then the stinger, the wire is either positive or negative depending on how you have it set up. But you have to have both connected to the metal in order for the weld to produce. So first, put the ground clamp on your work. You got to make sure it has a good connection with the metal. I've scraped off some of the paint off this metal so that the clamp can really get a good connection with it. Now that we're ready to start welding, let's talk about technique. Alright, here I have a drawing of basically two pieces of metal which are set side by side. Okay, let's pretend like this marker is the stinger that you're going to be holding to weld with. Alright, the technique that I use that works really well is you make kind of a moon shape. Alright, shape of a moon is something like this, so that's the kind of shape you're going for. So let's say I'm welding, the weld is going to be kind of like this, side to side, side to side. As you can see, it has an arc. It's not just straight like this. There's an arc to it. Okay, so then I just do that for the whole thing, arc, 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 arc. And this is going to be kind of time consuming depending on how large the weld is. You just got to take your time and make sure you do it right. Another thing that's important is your weld angle. So when you're welding, you have the stinger at an angle kind of like this. You don't want to have it straight up like this. You don't want to have it super low like this. You want to have it at about this angle. And then there's this other thing called stick out, which is how far the wire sticks out before you have it touching the metal while you're welding. So you don't want to have the amount of stick out you want is probably like about a 1/2 inch. So from this point to this point, the end of the wire, you want it to be about a 1/2 inch, which would be somewhere about right there. That's the amount of distance you want between the metal and this part, about a 1/2 inch. That's called the stick out. You may have to adjust your stick out depending on the situation, but most commonly that's about what you need, about a 1/2 inch. Okay, so have the right amount of stick out, have the right angle, and then another thing is that you want to pull the bead. You don't want to push it. The bead is basically a liquid ball of metal. While you're welding, the metal gets so hot that it turns into liquid in the spot that you're welding at. It's not like the whole piece of metal is going to turn to liquid, but the spot where the wire is hitting, it's going to start turning to liquid. So once it turns to liquid, it kind of turns into a little ball. And when it turns into that ball, that's what's called the bead. So the bead is what you kind of like move the bead around. The bead travels from one piece of metal to the other. Okay, so you want to make sure you keep that bead going in order to make sure that both pieces of metal are melting together properly. And the reason I said you have to pull the bead and not push it is that while you're welding, as you can see, I have the angle this way and everything. You pull going this way. You know, if you weld going forward, you're pushing the bead. If you weld going backwards, you're pulling it. So you want to make sure you pull the bead. Alright, now that the welds are done, it's time to clean them up and see how they came out. Start off with this. When you use a wire brush, it's a good idea to wear a pair of safety glasses. Things might fly off the metal and get into your eyes. Okay. First off, you notice all these little balls of metal that are all over the place. Those are known as spatter, and that comes from the welding. You can scrape that off. But yeah, these welds didn't come out real great. As you can see, this weld is fat in some areas, which usually means that the metal the metal you were welding didn't really melt properly. Either that, or you could have been sitting for too long in that one spot and building up metal as the wire was coming out. Okay. Next is this shovel project I've been meaning to do. This had a wooden handle. The handle broke off, so I decided to use a top rail from a chain link fence to make a new handle. So let's see how this came out. The welds on this came out pretty good. They're not perfect, but certainly good enough for a shovel. And yeah, it looks like the two pieces of metal I was welding together, it looks like they melted together pretty well. So that's a success. And now this one, just a couple scrap pieces of metal I welded together. This weld came out the best. As you can see, two metals melted together very well. And this is basically what your weld should look like. This weld's a little bit messy, it's not perfect, but it came out pretty good. It's a pretty good strong weld. Okay. And now I welded on this thin piece of metal to demonstrate how sometimes while you're welding you can start getting these holes where you're welding at, and this is caused by the metal that you're welding. It gets so hot that the metal turns to liquid and it starts dripping out of place. As you can see, that those balls right there were the metal that melted through. This is called burn through, and the way you prevent this is by lowering the power on the welder, because if you got the power set too high, then it can make the metal get too hot and burn through like this. Another thing you can do is, once you're welding, if the weld is going good and then it starts burning through, you can stop for a couple seconds and then start welding again. And when you start seeing a hole again, stop, wait a second, keep welding, because when you stop, it allows the metal to cool a bit. And so then when you keep welding, you can weld a little while before more holes show up. You could also press the trigger on and off like this on the stinger, and that'll also allow a little bit of time for the metal to cool down so that it won't burn through. Another problem you might have while you're welding is that while you're welding, you may feel the stinger pushing like this. It might be pushing against you, and a lot of times that means that you have your wire speed set too high. And so if you have your wire speed set too high, you just lower it a bit and try welding again, see if it's still jumping around like that. Also, if you have your wire speed too low, then while you're welding, the weld won't be consistent. You know, it won't keep welding. It'll be kind of choppy. Like it'll weld a little bit and it'll be like an on and off, like so you got to make sure your wire speed is right also. Alright, last thing I'm going to do is to spray this galvanizing paint on the weld to help protect it from rusting. And this isn't something you need to do in all cases. If the thing that you've welded, if you're going to end up painting the whole thing, then you may not have to use this galvanizing stuff. You might be able to just use primer and paint, and that should protect it well enough.